Hello friends, welcome to Shiksharthi. In this video, we'll be talking about numbers. So let's start. So as we had discussed in the earlier video, wherein we have already talked about what are prime numbers, what are composite numbers, what are even numbers, odd numbers, natural numbers, whole numbers and integers, we will start off this session discussing how to check whether a given natural number is prime or not. Just to recollect, what is a prime number? A prime number is a number which is divisible by itself and 1. So there are exactly two factors of a prime number. Right? So this is the point that we were supposed to discuss. Right? This is the point that we are supposed to discuss, which we are going to discuss here. Now the number that has been given here is 25. So if I have to find out whether the number 25 is a prime number or not, what is the first step? The first step is I will write down the squares of all the prime numbers starting from the minimum prime number. And as discussed earlier, we have talked about the smallest prime number is 2, the next prime number is 3, the next prime number is 5, and these are the first 25 prime numbers. Now when I say first 25 prime numbers, I am talking about prime numbers between 1 and 100. So once you would have understood how to find out whether a number is prime or not, these are all the practice examples that you can take. Okay, so the number that has been given to us is 25 and we need to find out whether it is prime or not. The first step as discussed here is you will write down the squares of all the prime numbers till. Now here P is a prime number. Now what is the limit for this? So for example, if there is a 25, I know 2 square is lesser than the 25, 3 square is lesser than the 25. So what is the limit here? The limit here would be, what is the set that you are going to take here? So I am talking about the first step. So you start off with a 2 square, then a 3 square, then a 5 square. The first step ends here. So you have to end it on the square of a prime number such that that square of a prime number is lesser than or equal to the number given. I repeat, when you are finding out whether a number is prime or not, what do you need to do? You need to start off with the squares of minimum prime numbers and then the subsequent prime number squares. So you start off with a 2 square, then a 3 square, then a 5 square. Then you would see that 5 square is equal to a 25. So what is the ultimate value that you need to take here? The value that you need to take here is a prime number square such that the prime number square is less than or equal to the number given. What is the second step here? You have to write down the square roots of all these numbers. So when I write down the square root of 2 square, it is a 2, then a 3, then a 5. So the second step that I have written here is 2 square, 3 square and such on, such like this, P square, and you have to write down the square root of all these prime number squares that you would have written, and I am assuming that this is the set. These are the different values of x. X is a number that I have assumed here. So what are the three values of x that I can take here? I can take the values of x as 2, 3 and 5. What is the last step that you are supposed to do? You are supposed to divide the number 25 by all these values of x that you have taken, and you have to check whether it is divisible or not. So is 25 divisible by 2? No. Is 25 divisible by 3? No. Is 25 divisible by 5? Yes. What will you say now? Now you know that a prime number is divisible by, had this been a prime number, it should have been divisible by 1 and 25 only. But other than 1 and 25, here you are getting one more number by which it is divisible. And that one more number here is a 5. So how many factors does this number have now? It has exactly 3 factors, which makes it a composite number. So can I say, is this number a prime number? No. If it is not a prime number, is it a composite number? It is not a prime number and it is not equal to 1. So then I can say, yes, it is a composite number. We will take one more example. Now if somebody gives me a question like, let's say, as I said, these are 25 numbers, these are 25 prime numbers between 1 and 100. Take any one from here to practice and find out whether a number is prime or not. So if somebody gives me 79 as a number, what will I do? The first step is 2 square, 3 square, next prime number is 5 square, then 7 square. The next prime number that I get here is 11. But then 11 square becomes greater. And what was the limiting value? You need to take the squares of only those prime numbers such that the prime number square taken should be less than or equal to the number given. So second step is you have to write down the square root of all these prime numbers that you would have taken, which is 2, 3, 5 and 7. So now these are the different values of x that you are supposed to take. What is the third step here? You have to divide this number by all these numbers that you have got here. All these values of x. So when I divide it by 2, is it divisible? No. Is it divisible by 3? No. Is it divisible by 5? No. Is it divisible by 7? No. It is not divisible by any of these values of x. So can I say it is a prime number? Yes, it is a prime number. And here it was, no, it is not a prime number. Right? I hope you have understood this and you will be able to take this discussion forward, and you can take all these examples as a test for prime numbers. I mean, you need to check whether these numbers are prime or not. Okay, taking the discussion forward, there are some properties that I would like to discuss. Now, what are the properties? Now, as discussed earlier, capital E is an even number. So when I am adding a set of even numbers, what is the result that I would get? I'll get an even number only. Now, when I am subtracting the set of even numbers, these are n different even numbers that you would have taken. So I can take 2 even numbers, 4 even numbers, 5 even numbers. I can take any number of even numbers. The sum of even numbers and the subtraction of even numbers, the result will always be an even number. Now when I say even number, please relate with the last discussion that I have had with you. That even number could be what? Either an even natural number or an even whole number or an even integer. If I have to see the broader side of this, I can call them as the answer will always be an even integer. I hope this has been understood. Moving on with the discussion and moving on to point number 2. If I take the product of 2 even numbers or more than 2 even numbers, what would be the result? The result would be an even number only. To be more precise here now, we'll be using a new terminology because I know that all natural numbers and all whole numbers are integers, right? But can I say all integers are whole numbers and all integers are natural numbers? No, I can't. So as advised, maths becomes pretty interesting if you are able to bring the element of logic here in it. It becomes pretty interesting, and this interesting part, gives you an impetus to take it to a next level. Yeah, okay. So now third point here is O is for odd numbers. So if I am taking n odd numbers, what would be the result? So let us say I take 2 odd numbers. What is the result? 4. If I take 3 odd numbers, what is the result? 9. So if I take and at the same time I could have subtracted them also. That doesn't make any difference to the interpretation. Now if I would have said 1 minus 3 gives me how much? Minus 2. And at the same time 1 minus 3 minus 5 gives me how much? Minus 7. Please focus only on these values. So if I take 2 odd numbers and if I add them or subtract them, if I take 2 odd numbers and if I add them or subtract them, what is the answer that you will get? An even integer? Yes? So there is no restriction. I could have taken both of them as equal also. Right? But if I would have taken 3 odd numbers and then I take their sum or I take their difference, the result would be an odd integer. What does this signify? It signifies if the number of odd numbers that I would have taken is an even number, then the result is even. And if the count of odd numbers that I would have taken is odd, the count means 1, 2, 3. So if the count of odd numbers is odd, then their sum and or their addition will give you an odd number. But if the count of the odd numbers that you would have taken is an even count means 2 odd numbers, 4 odd numbers, 100 odd numbers, then their addition, subtraction or a combination of addition and subtraction will give you a result which will be an even integer. I hope this has been understood. Next point here is, if I take the product of all odd numbers, then the resulting will be an odd integer or an odd number. Next, if I take even numbers and then I take odd numbers and I add them or I subtract them, what would be the result? The result would be either even or odd. This is just based on, can I say this is nothing but the combination of point number 2 and point number 3, which I have already discussed. So you can take it to a next level. Next, if I take one even number and the remaining numbers are odd numbers only, or if I take n number of even numbers and n number of odd numbers, what will be their product be? The product will always be an even number, or I can say an even integer to be more precise. Okay. Now the last point that we are going to discuss here, which we'll be spending some time on this, we are going to discuss the concept of co-primes, because next we'll be doing factorization, remainders and so on. Before that, or HCF LCM, we'll be using all these things that we would have talked about in different sessions or different videos on numbers. So please make sure that you watch them in a sequence so that the next video that comes on the same topic, it becomes easier for you to understand the same. Okay, so we are going to discuss the concept of co-primes or relatively primes. Now what is the meaning of co-primes? So if there are two numbers, let us say A and B, such that their HCF is highest common factor, is equal to a 1. For example, 2 and 3, their HCF is a 1. The common factor between them, the highest common factor between them, if it is a 1, then they'll be known as co-primes. What a relatively prime? If I give you three numbers, three or more numbers such that their HCF is a 1. For example, I can take a 2, 3, 5 or I take a 2, 3, 4. And as advised earlier in my earlier videos also, to learn something new, you need not take big examples. By taking merely small examples, you can learn big time. Big things. Okay. So, what is the concept of co-primes? The word co comes into picture only when you talk about two things at the same time. So, if two numbers have an HCF as 1, then they'll be termed as co-primes. At the same time, if three or more numbers have the HCF, which is highest common factor, equal to 1, then they'll be termed as relatively prime numbers. Having understood this, then there are few points that I have noted down here. 1, 2, 3, 4, 5, 6, 7. And this is quite a comprehensive discussion to give you a further insight in numbers. And the more you dive deep, the more you learn. We have talked about this thing earlier also in our videos. So I am taking very small examples. Now 2, 3 is just like saying one prime number, another prime number. Further on, I am saying, what is this? Even, odd. So if I take one prime number and another prime number, can I say they'll always be co-primes to each other? Yes. Now tick mark, I'm using it for a co-prime. And I'll not be using any mark for in case if they are not co-primes. Can I say 3 and 5 are co-primes? Yes, because their HCF is a 1. And what is this variety? This variety is I'm taking one prime number with another prime number. The first case was even, odd. And the second case here is both the numbers are odd. Third case that I am taking here is there are three examples that I have taken for the next case. And these three examples are basically talking about one of them is a prime number and the other is composite. Now when I say one is a prime number and another is composite, these are the three examples that I have taken. Can I say one prime number along with another composite number, which is just like saying even, odd? Is this co-prime? Yes. Now another is prime number along with a composite number. So if I've taken one number as 2 and the other number is a 2 square, which is a variety of a composite number only, as done in the earlier video, which is the smallest composite number that you would get, 4. So this is just like saying you're taking one prime number with another composite number, but both of them are even numbers. So two even numbers will never be co-primes. So as discussed earlier, we will not be putting any mark. We will not be putting a mark in case if they are not co-primes. Next, I am taking 3, 3 square. Is their HCF equal to 1? No. Here the HCF is a 2. Here the HCF is a 3. And this example is both the numbers are odd. And they fall under the category of one of the numbers is prime and the other number is a composite number. Okay, the last variety that I am taking here is both the numbers that I am taking here are composite numbers. So the first example that I have taken here is 2 square comma 3 square, which is just like saying one between them is even and the other one is odd. Are they co-primes? Yes, because their HCF is 1. And the last case that I am discussing here is two composite numbers. Both of them can be odd also. Right? So are they co-primes to each other? Yes, because their HCF is 1. Does this necessarily mean that two odd numbers will always be co-primes to each other? No. How? I could have taken one example as 3 square and the other number as 3 cube. Now this falls under the same category, which is one composite number, another composite number, and this is just like saying both of them are odd. So if both the numbers given are odd numbers, will they always be co-primes to each other? No, because here the HCF is 3. So this is just a counter that I have brought for this example. So let's say this example is H. Now what is your homework for today? Your homework for today is you will try and figure out more examples, seeing that can I say that one even number and another odd number, they'll always be co-primes to each other? You'll try and figure this out. I'll write down. Will they always be co-primes to each other? One even number and the other one is odd. Can I say one odd number and another odd numbers? Will they always be co-primes to each other? And the last case that you can write, we know that one even number, another even number can never be co-primes to each other because the common factor will always be a 2 as discussed in the last video. Even numbers are always divisible by 2. So I'm not giving you that as an example. What is another example that you can take? There is no other example that you can take. So you just need to find out, if I say two given numbers, one of them is even and the other one is odd, will they always be co-primes to each other? You need to tell me. Second case here is, can two odd numbers be co-primes? You need to find out this. And the third thing that you need to find out here is, there are so many examples, others which you can take it as practice examples to find out whether these numbers are really primes or not. Given the fact that you already know that these are first 25 prime numbers. When I say first 25, I am talking about first 100 natural numbers there are 25 prime numbers. I hope you understood whatever has been explained. If you feel that something really knowledgeable has been discussed in this video, please do not forget to like, share and subscribe to the channel. If you have already done so, please select the bell icon and select all so that you start receiving regular updates from us. If you want us to do some specific videos in terms of some specific topics, please put it in the comment section. Thank you so much. Until next time we meet, goodbye.